Hi everyone, what's up? All good? Okay. So today we are going to solve the third question of weekly contest 385, which is most frequent line. Let's see what is this question saying. You are given a m cross n zero indexed to the matrix mat. Okay. From every cell, you can create numbers in the following way. There could be at most eight paths from the cells, namely east, southeast, south, southwest, west, northwest, north, and northeast. Okay. Select a path from them and append digits in this path to the number being formed by traveling in this direction. Okay. Note that the numbers are generated at every step. For example, if the digits along the path are 1, 9, 1, then there will be three numbers generated along the way 1, 19, 191. Okay. Return the most frequent prime number greater than 10 out of all the numbers created by traversing the matrix or minus 1 if no such prime number exists. Okay. If there are multiple prime numbers with the highest frequency, then return the largest among them. It is invalid to change the direction during the move. Okay, this is our biggest hint because it makes the question much simpler. Okay, so let's see what is this question. Like we need to go to every index. And from the every index, we can go in all the eight directions, which is east, west, north, south, southeast, and all the eight directions. Okay, and then we need to append these digits in when we are going in the particular direction, then we need to append that digits from to the previous digit and check whether it is prime or not. And if it is prime, then we need to count its frequency and return the most frequent prime number greater than 10. And if there is no prime number, then we need to return the minus 1. And if two or more prime numbers have the same frequency, highest frequency, then we need to return the largest prime number. So it is a very simple question that we need to go to every element, and from that every element, we need to check in all the eight directions to check for every prime number. Like if we start from this one, then we will check whether it is prime or not. But there's a condition that we need to check for the prime number greater than 10 only. Okay. So we will, let's say, we are going in the south direction. So we will append 9 in 1. So we will check for 1 9 whether it is prime or not. If it is, then we will count it. Then we will further go in south direction to check whether it is prime or not. 191. We will append 1 to the previous number. So in this way, as we are going in south direction, so from this one, we need to go in the east direction, we need to go in the southeast direction, west direction, north direction. So in this way, at every index, we need to go in all the eight directions and append the digit to the previous number and check whether it is prime or not. And as it is given that it is invalid to change the direction during the move. So if we are going in the south direction, then we need to go in the south direction only. We can't change the direction in between. Like we can't go like this, we can't go like this. We need to go in a single straight direction only. So it is a very simple question. We just need to frame it in our code. So let's see how we can do it. Okay. So first of all, I will store the size of the matrix as n, and m is equals to mat 0 dot size. Good. So I will declare the result variable as 0. Now we need to go to every integer. So we need to iterate in our matrix for that. J is less than m, j plus plus. Okay, good. Now we need to, if we are at a particular index, then we need to go for all the eight directions. So for first of all, we define our directions array like mine, so that we can simply track our directions. I think you are aware of these arrays, like we can define it to travel in all the eight directions. -1, 0, 1, -1, 1, -1, 0, 1. Okay, So like minus one will take you to the, like if we are at this in, let's suppose if we are at this 9, so minus 1 will take you to the which direction? Tell me if we are. So minus 1 will take you to this direction, as I is also decrementing and j is also. So in this way we can travel in all the 8 directions. Okay. So if we are at a particular index, then we need to go for all the 8 directions. Okay, so let's just start traversing in all those 8 directions. Okay, good. Now the current digit which we have is mat of I and j. Okay, so like is a single digit, we don't need to check for a single digit, as it is said that we need to check for the prime numbers greater than 10 only. Okay, so we will declare our row as I plus del row of k int call is equals to j plus del call of k. Okay. Now, if we have started moving in one direction, let's say k is equals to 1, it means we have started moving in this direction, southwest. Okay. So we will continue to move in that direction only till we reach the end. So what we will apply? We will apply while row is greater than or equals to 0, and then row is less than n, and then column is greater than or equals to 0, and then column is less than m. So we will continue going in that direction till we reach the end. Now we need to append that digit to our previous digit. So how we can do that? We can simply first of all multiply our current digit by 10. We can simply multiply our current digit by 10 and append that digit to the previous digit now. Got it? Like if we have currently we have 9. So now we need to append 1 to it. So what will it become? 91. So how we can make it? 9 multiplied by 10 plus 1, right? It will become 91. So if we are doing that. Now if digit is greater than 10, then we need to check for whether it is prime or not. If it is prime, then we will simply increment our. No, we don't increment our result here. We need to track for the frequency of every prime number and then return the prime number with the highest frequency. So we will declare an unordered map here to track the frequency of the prime number. If it is prime, then we will simply increment its frequency in our map. Okay, got it. Yeah, cool. Now, after coming out of this loop, it will again go in the next direction and continue going in that direction till we reach the end and increment the frequency. So, in this way, we will be tracking all the prime numbers in all the 8 directions. Now, we need to find the prime number with the highest frequency. Okay, so let's declare a frequency variable as 0 and the result is minus 1, as we if we don't have any prime number, so we need to return minus 1. So now we need to iterate in our map for finding the prime number with the highest frequency. So if the frequency of current prime number, if the frequency at which we are is greater than the frequency which we have already stored, so we will simply take that prime number because its frequency is higher than which we have got till now. But if its frequency is equals to the frequency which we have already, so we need to check whether the prime number is greater or not, which we have already, because in the case of the same frequency, we need to return the largest among them. Okay, so we will check whether the prime number is greater or not. If it is so, then we will increment, well, then we will update our result. Otherwise, no. At the end, finally, we will return our result. It means the prime number with the highest frequency. Now we need to implement this function is prime. So as it is returning true or false, so its type will be boolean. So integer n. So I hope you know how to implement the isPrime function. So we will check for I is equals to 2, I is less than square root, I is less than or equals to square root of n. So that we will take, we will be able to save our complexity. Otherwise, we can also run it till n I plus plus. So if n divided by I equals to 0, then it means it is divisible by some number. So we will return false. It means it is not a prime number. Otherwise, we will return true. Okay. Now let's try run this. Runtime error cannot be represented in type N. Okay, right. Yeah, we have missed one thing here. You can see that if we implemented, if we have initialized row and column once, then we need to continue going in that direction. So for that, we need to continue incrementing that to del of row and column is equals to column plus del col. Okay, we need to continue going in that direction continuously. Okay, so now let's try run this. 19. What was expected? Yeah, 19. Cool. Let's try for all the cases. 19 minus 1, 97. Yeah, cool. Now let's try something else. Yeah, it's working fine. Now let's talk about its time and space complexity. First of all, I think you should pause video and think about its time and space complexity, then come back to this video. So you can see that we are running these two loops. So its complexity will be big of n into m into, and this third loop is we are learning till 8, so which is a constant, so we can skip that. So its complexity will be n into m into, and we are using this is prime function whose complexity will be root n. Okay, so its overall complexity will become n into m into, let's say the prime number is root k because n is this, so it will just make confusion. So its complexity will be k. And what will be its space complexity? As you can see that we have used a map which is showing all the prime numbers. So let's say if we have total of 3 prime numbers, so its space complexity will become big O of k. Okay, so this was all about this question. It is the third question of today's contest, but it was not that much tough according to the approach, but it is just you need to frame it in your code. So if I hope you get it. If you still have any doubts, you can post in the comment section. I will surely try to answer them. Till then, bye bye guys. See you soon in the next video.